Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and his brother Joel Chaiken to help you learn how to get practice approaching SAT math questions. This is an SAT math question from the calculator section. It has to do with the circle, and the equation of the circle is that thing. What is the radius of the circle? So Seth and I talked a little bit about this beforehand, and we think really the most efficient way, probably the proper way to do it, is to complete the square and do the equation of the circle. Completing the square is a pain. Really is.
You have to do it twice.
Yeah, you have to do it twice. It's a royal pain. There are different ways to complete the square, everyone. I always have a fear of completing the square.
It's kind of fun.
Yeah, it's fun when you do it right. Yeah. There may be a really brilliant way to do this, maybe by brute force or checking the answers. I don't know what it is. And then there's actually another way to do this, by the way. The other way to do this, because it's a calculator section, you could graph that. You could use your graphing calculator to graph that thing, and you'll get the answer right on the screen. But we'll talk about that afterwards.
Well, there is a problem. Not every calculator
we're gonna talk.
Makes it easy to graph this equation.
I know. We'll talk about that after.
Yeah.
We'll talk about.
So
we'll do the calculator section. Well, Seth's right. It turns out our research shows that okay, I'll tell you what. If you have a TI-84 CE plus, then you can use a calculator. But our research shows that the older versions will not do this. Okay, so we'll talk about that later. So let's get going to completing the square. It's always good to procrastinate completing the square. Okay, small thing, because we have to be very neat. This is an algebra question. We have to get the equation in this form: x minus a squared plus y minus b squared is equal to r squared. This is a very nice form for the equation of a circle. Why is this so nice? Because it's nice because you can pick off the center of the circle, which is AB, and you can pick off the radius immediately. So somehow we have to get
but
this.
The radius is r.
Yeah, the radius is r. Yeah,
we have to say that. How do you pick it off? It's r.
It's r. Yeah. Well, if you get it in this form, then you will pick off the radius. You'll see. It'll all work out. Okay.
Yeah. Well,
ready?
Yeah.
So let's write it out.
Well, that equation. What does that equation say? It says that the vertical, the square of the vertical distance from the center to a point, plus the square of the horizontal distance from the center to the same point, is equal to the square of the radius.
Yeah.
This is the statement of the Pythagorean theorem.
Whoa. For
the 2 points, the center AB, and a point on the circle XY.
Wow!
So it says
really
that there's a right triangle with hypotenuse R.
Wow!
For every there it is, for every point on the circle. For every point on the circle, X and Y,
right?
Every point on the circle, there is one of these right triangles, and the equation states the Pythagorean theorem for that right triangle.
I think, Seth, what you just did was
so that's where this famous form, convenient form for circle equations comes from.
I never realized that before. But what you just did was something called overkill. I don't think anybody realized.
But it helps you remember. What the form is.
I've lived my whole life remembering it without that, but that's. But thank you, Seth. No. That's really helpful. That I've never actually noticed that before. So that's really cool. All right. I just know that they always have the question, the locus. What's the locus of points, the equidistant from a center? And it's the circle. Yeah. But Seth, that's actually fantastic insight. It's just that right now, nobody's going to be saying that when you the problem. But that's a great way. That's not a bad way to remember it. Yeah, Pythagorean theorem. That's cool. Unfortunately, that doesn't help you complete the square.
Well, it helps you because it tells you what your goal is.
Well, yeah, of course, obviously, yeah. So let's go ahead and do the complete the square. Wish me luck. Okay, so let's write it like this. Okay. Y squared minus 2y is equal to negative 1. We have to get it in the form.
No, I wouldn't do that. I'd write it this way.
Wouldn't do it?
X squared.
How would you do it?
Plus 4y. I'm sorry.
What are you talking about? You just made a mistake.
Hold on. Let me write it myself.
Go ahead.
X squared plus 4y. Pick off the x squared and the 4y. And then leave a big gap. Leave a big gap.
Okay. Big gap.
And write y squared minus 2y. And leave a big gap. And then write equals. There's a big gap. There's a big gap here. And a big gap here. And I'll continue on the next line. Equals minus 1. And after the minus 1, there'll also be a big gap.
Okay.
Okay.
I see
Why did I put those big gaps in there?
Maybe we should do this problem where I do it my way, you do it your way. Because everybody has a different way of completing the square. So should we do that?
All right. You want to do your way first?
Yeah, no. Why don't you erase that? We'll make a line, and then you do it your way, I'll do it my way. No, it's really useful.
Well, we need space.
We will. We'll write small.
No.
So why don't you erase what you have, and we'll write small. I promise I'll write small. I do. I really do promise. So
all right. So you want to squeeze your way in there?
Yeah. Here. Oh no, Seth. Can you just erase what you just wrote?
I took up so much space.
Yeah, I know. Erase it. Do the back key. Use the back key. Use back. Go back. This thing. The back.
You want me to do that?
Yeah, you. Yeah.
Okay.
You have to do it. Otherwise, if I erase it, well, that's right.
All
Keep going. Keep going. Keep going.
Two more.
Keep going. Okay, stop.
One more.
Wait, one more. Go on, and then I go like this.
All right.
Okay, here we go. We're gonna make a line down the center. Okay? And we're gonna crush in. Okay? And if you want more space, Seth, we'll give you more space. Okay? We'll give you more space. Okay? So I'm gonna make it really tiny. Ready? So you have to force this. You have to get something. So when you multiply, you get an x squared plus 4x. So you do x plus 2 squared. Okay? Now, that x plus 2 squared actually introduces a plus 4. See that? Because if you FOIL this out, you get x squared plus 4x plus 4, which means that you have to add a 4 on the other side.
Yeah.
Okay, to take that into account. Now let's play games with the y. Y minus 1. Y minus 1 squared. Because y minus 1 squared forces the y squared minus 2y when you FOIL it out. But that adds a 1 on this side. So to balance the equation, you add a 1 on this side. Oh, so that's conveniently a 4. Done. We're done because we're done. The radius is 2 because this is the equation in the form we care about. This thing plus this thing is 4, and that's equal to r squared, so r is 2. Done. Okay? Done. So what I like to do is I like to balance it. I like to balance the equation. When you add this thing forces something.
Yeah.
So then you add it to the other side. I know what Seth's going to do. Okay, Seth. Go ahead.
Okay, my way. Okay, so here we go. What we want to do is find not the same equation as was given, but an equivalent equation. That is an equation that has the same solutions as the original. But I want the equivalent equation to have the sum of squares equals radius square form. And so I take the original equation and begin by rewriting it so that I could start to change it into an equivalent equation. So I put the terms with x's first. I leave a gap. This is not a clothing store, but a space on your worksheet.
Okay.
Plus y squared. Right, y squared minus 2y plus a gap. equals -1.
Okay.
All right. Now, what we want is to put something in this gap without changing the solution set to the equation. And so what I put in the gap is some number so that I'm going to put in a question mark, and then I'm going to subtract the same question mark. So what I'm going to choose the first question mark so that this thing is a square.
Right.
So how do you do that? Well, you do that by doing what Joel said. You realize that if you put a 2 here, I'm sorry, you realize, that if you put a 2 here,
4.
then
it's a 4.
It will be a square of the form x
no, it's a 4.
plus 2 squared.
It's a 4. It's a 4, not a 2.
Oh.
It's a 4.
Okay. You're right. Yeah, you have to be careful. Yeah, so it was going so if you put a 4 here, then this stuff will be of the form x plus 2 squared. But to keep the equation equivalent, you also have to subtract the 4, so you don't change the equation. So put parentheses around here. Now we do is completing the square a second time. This time, the question mark number is a 1. Make sure to subtract the 1 so that you don't really change the equation. And then we have x squared. Then we have the perfect square. The perfect square that we get here is y minus 1, which is what Joel got. So y minus 1 squared equals this gadget, and x plus 2 squared equals this gadget. Now we get an equivalent equation by transferring the -4 and the -1 to the other side. Subtract, add 4 and add 1. Let's see, am I right?
Yeah.
Yeah, so add 4 and add 1
don't do it in your head.
to here.
Don't do it in your head. Do it on paper.
Plus 4.
Yep.
Plus 1.
Right.
And then simplify this. -1 cancels with the 1, so we get a 4.
Right.
Now 4 is 2 squared. Remember that the number you get on the right in this form is r squared.
Right. Yeah, really important.
You have to remember that. So you need to find the number whose square is 4, and that is 2.
Right. Exactly. Good job. Good job.
So the technique for solving a question like that is to complete the square twice.
Yeah.
Track the modifications to the square that only contains x's, and the modification to make the square that only contains y. Add up the modifications, put them all on the right hand side to get the square or the radius. Figure out the square of the radius is, take the square root, and then that's the answer.
That's the answer, right? I would love to have seen how the SAT suggested to solve it. This is actually an old test. I don't have the answers. I have the answers to these questions, but I don't have their explanation.
Yeah.
I assume they also completed the square. It's just standard stuff that you learn in school. You just have to remember how to do it. Okay, yeah. So the calculator option. We did a little bit of research, and we found out by Googling TI-84, which is the calculator virtually everybody has, like the SAT, TI-84, graph a circle or something like that in Google. And it turns out our research shows that if you have the TI-84 plus CE, which is a little bit of a newer model, a little more expensive, and probably anything higher than that. There is an option.
I think you should zoom in a lot more. There we go. All the way up.
There is an option to graph a circle. We don't know how to do it, of course, because we're not the best. We're not into the calculator stuff.
Well, I'm sure if we got it to the screen, we would just, all you do is you push the down button and you then enter.
No. What you do is you watch the video and you learn how to do it. Okay, but then you have to remember how to do it. Frankly, it's easier to remember complete the square than remember all the buttons you have to push on the stupid calculator.
Well, let's look at that. Let's look at those two things on the screen, blown up, so we could talk about them.
Wait. Let's go back more. That's actually a detail. The bottom line is, if you want to know,
I want to point out something about what's on the screen.
You will. Well, wait a second. You will. Do you have a chance? You will. The bottom line is, if you want to know how to do this problem using a calculator, you Google what I just said, draw a circle, TI-84, or you could just go directly into this thing, and somebody made a video on how to use it. Shows you exactly how to do this. Okay, I think the older versions, we could not find videos to show you what to do for the older versions, the regular old TI-84 Plus. So if that's what you want to do, you do it, and then you follow the directions, and it'll tell you exactly what to do. Now, Seth is going to talk a little bit more about, what this means. Go ahead.
Yeah. Okay. Well, the second form for equations of circles, is the general form. And the SAT question that they gave you, that we did, presents an equation that is in the form number 2.
Sure.
Well, the capability of the calculator to plot the solution when it's in form 2 is really, really helpful.
Yeah.
However, the talent of the calculator to plot the solution when the equation is in form 1, that is really, really stupid. It's a waste to make use of that feature. Why? Because when the equation is known in form 1, well, right from the equation, you could read off everything you need to know, everything about the geometry of the solution. Okay. The point with coordinates HK is the center.
Right.
And the radius is R.
Right.
So what do you need a calculator to plot it for?
I know why.
Okay, tell me why.
I know why. Because I'm not the best with calculators, okay? But I can definitely see a question where they ask, what is the intersection of a circle and this line? Okay?
Yeah.
So then first you graph the stupid circle, and then you graph the line, and then you go to the calculator and you pick off the intersections. Okay?
Yeah. So that's the one excuse for it.
Okay. Okay. But then the other thing, you got to be really careful if you graph this thing, knowing calculators, because computers are like disasters. You may actually graph it. It may actually graph like a little itty bitty circle like that, and you'll never be able to find it. You have to zoom in. You have to set your axes. By the time you set your axes and play with the calculator, you might as well complete the square. But if you're good with calculators and you know how to zoom, you know how to set your axes, it can be really frustrating to graph this thing, and the circle comes out so tiny that you can't pick anything up because you have to reset the
Well, if it has the form, 1. You could tell what the size of the circle is.
Yeah, but then you have to know how to change and zoom into your
axes. Yeah. If you have a calculator, you can't. How much a calculator is useful depends on how much of it you know how to use.
Right, exactly. That's exactly right. And you probably realize already, Seth and I barely know how to use the graphing calculators because we never grew up that way. And because most of these questions can be done.
But we know what to look for. If we wanted to use a graphing calculator, even though we didn't know exactly the sequence of buttons, we know what we want.
Right.
So we could experiment more efficiently, or we could more easily follow instructions.
Yeah, watch your video. Yeah. But then you have to follow the instructions that have change the axes and zoom in and zoom out and stuff. You need experience.
Yeah.
But yeah, we know what we need to do, and we also know that if you want to know how to use a calculator, you go to Google and you type in the calculator version you have and the problem you have, and there'll be more than enough videos that'll tell you exactly what to do. So we know that at least. We know how to get the answer on how to calculate. Oops, someone moved it. So anyway, that's it.
Oh,
right?
sorry. I did that. I screwed it up.
Don't worry about it. Okay, so, calculator would help, but frankly, well, again, we've said it already that for us...
Yeah, we don't know if the SAT creators intended that takers use the calculator with a calculator that has the form, the general form, not the center radius form.
Right. That's
versus
right.
use
That's
the
right.
completing the square.
Yeah.
Well, the problem was chosen so that completing the square is easy.
Yeah. I was wondering. This is what I asked before. I wonder if there's a way to use some brilliant insight so that you don't have to complete the square to see the answer, but it's not worth us even talking about it because by the time you come up with that brilliant method, you might as well just complete the square. So I don't think it's worth our time exploring whether there's some brilliant Einstein.
See, the radius,
yeah, it's not worth our time.
Yeah.
Okay. Because because by the time
that's what mathematicians are interested in.
Right, exactly. That's why they'll look at this thing and say, "Hey, is there a cool way?" And you'll spend months figuring it out.
Yeah. Well. You could take the general form and compare it with the general form of the polynomial and the circle of the polynomial whose solution set is a circle, and the form in terms of center and radius, and compare them, and then write the formulas in terms of the coefficients for completing the square, and that will give you a formula.
Yeah. For
the radius.
Yeah, but
so if that's what you're looking for, that's pretty easy.
Yeah, but
you could plug in, the coefficients. A, the coefficient for x squared and y squared. B, the coefficient of x.
Right.
C, the coefficient of y. And D, the constant coefficient. And so for coefficients, there's a formula for
right.
For r squared, and therefore square root of it is r.
Right. Yeah, absolutely. Yes, like quadratic formula. You don't really need to know the quadratic formula. You can complete the square for quadratic equation.
Well, the quadratic formula can be derived by completing the square once.
Exactly. So then, but forget it. We're just wasting everyone's time.
Yeah.
Okay. So have a good day.
Okay.
Like us, dislike us. Give us comments so that we know how to improve this stuff. And then if you have any SAT math questions, email them to us at satmathquestion@gmail.com. Have a great day. Right?
Okay, bye, everybody.
Bye-bye.